Yes, now we are starting with laboratory preparation of carbon dioxide. Okay, now the first thing over here is what are the chemicals used for preparation of carbon dioxide. The chemicals that are used are marble chips, that's CaCO3, and dilute HCl. Okay, why both of these substances are used? Because they are least expensive. These are the cheapest substances from which we can get carbon dioxide. We have already written the reactions for these. Okay. The second thing is we are not using over here dilute H2SO4. Sulfuric acid is not used for this particular preparation of carbon dioxide. The reason for that is it is going to SO4, and of course the other things are same. Now see, calcium sulfate itself is insoluble in water. So whatever the marble chips are there, this calcium sulfate will get deposited on it, and whatever its remaining sulfuric acid which is there, it will not be able to come in contact with CaCO3 because calcium sulfate will form an upper layer that is going to stop the reaction. Why? Because calcium sulfate itself is insoluble in water. See, in the previous example, calcium carbonate that we are taking here, we are getting CaCl2, and of course the other products are water and carbon dioxide. Now calcium chloride that is formed in this case is soluble in water, so it will get removed. So more and more HCl will react and the reaction will be continued. It will not be stopped in the middle. If in this case, if you are using sulfuric acid, calcium sulfate is there, it will form a protective layer which will stop the reaction. So this is our first give reason question that is asked, that is calcium carbonate is used, but here sulfuric acid is not preferred because of formation of insoluble layer of calcium sulfate which will stop the reaction or which will slow down the reaction. Okay, so that is the first precaution that we are supposed to take. Okay, now the other care that should be taken, suppose if the reaction is slow enough, that is if the calcium carbonate is used in the form of big lumps, in that case the surface area that is provided for the reaction will be quite slow enough. So in that case what can we use? We can use powdered calcium carbonate. If the calcium carbonate is powdered, then also the reaction becomes sufficiently fast, and then the reaction will proceed easily. Okay, so this was the first thing, that was the precautions. Now we will go to the laboratory apparatus and other things. Now see, the apparatus that is used is, you can just draw any kind of figure that is there. Okay, either you can draw a conical flask or even a round bottom flask can be drawn. Okay, it is having a double holed cork. One of these will have thistle funnel which will be long enough. Okay, the other tube is going to be the delivery tube. Yes, bent delivery tube. The other flask which is there, okay, in this also there will be a double holed cork. Okay, this tube is long enough. The second tube which is there is short, and then similarly we are going to have a second flask. Okay, we'll see what the purposes of all of these flasks are. Okay, so this is also second flask is there. Here also a double holed cork is there, and then from here there will be collection of carbon dioxide. The second bent delivery tube is there. This is the gas jar which is going to collect carbon dioxide. Now this is the laboratory setup of the apparatus. Okay, I'll just discuss all the other things later. The first thing is I'm going to take a small marble chips which is going to be CaCO3. Now from here I'm going to pour dilute HCl, that is hydrochloric acid. Obviously you should take the precaution that the thistle funnel end is dipping inside the acid, otherwise all the carbon dioxide will go out from here only. Okay, now whatever carbon dioxide is formed over here, the first flask or the containing vessel which is there here is water. Okay, the second vessel in which this arrangement is kept is containing concentrated sulfuric acid, that is conc H2SO4. Okay, we'll see what the purposes of these are. Now first of all, we have already mentioned the reaction. CaCO3 will react with dilute HCl. Calcium chloride will form, which will remain in this flask only. Carbon dioxide and water which are formed, water will also remain here only. Okay, in case then carbon dioxide that is formed with the help of the delivery tube, first it will be delivered into the first flask A. Now whatever other impurities, impure gases which are there, they will get absorbed by water. Obviously some amount of carbon dioxide also gets absorbed in water also, but then once its solubility is reached, then the remaining carbon dioxide which is there will start coming out from here. And then in the second flask, that is B, okay, whatever moisture, water vapor, such kind of impurities which are there, for the drying purpose of carbon dioxide gas, we are using here concentrated sulfuric acid. So in flask B, concentrated sulfuric acid is acting as a drying agent. Now this is the gas jar. Okay, now here what you can see is carbon dioxide is approximately 1.5 times heavier than air. Okay, so obviously as carbon dioxide will come down, the air which is there in this gas jar will be pushed upwards. So always remember, whenever any gas that is heavier than air, the method of collection will always be upward displacement of air. It means air will be pushed up and the gas will come down because it is heavier than air. So this method of collection is known as upward displacement of